According to a 2023 study by NordPass, the average internet user manages roughly 168 passwords across their personal and professional accounts. You use Autofill every day to handle that load, quickly logging into your favorite websites and apps. But have you ever stopped to think about how it actually works? Most people treat it like a magic button, but underneath that one-click convenience sits a layered system of encryption, pattern recognition, and credential vaults that has been refined over nearly 3 decades of web browsing. The story of Autofill begins in 1994, when Netscape Navigator became one of the first mainstream browsers to let users save form data. That early implementation was primitive by today's standards, storing credentials in plain text files on the local hard drive with no encryption at all. Internet Explorer 5, released in 1999, introduced its own autocomplete feature for web forms, and by the mid-2000s Firefox and Opera had added encrypted password stores. The shift from plain text storage to encrypted databases was driven by high-profile breaches, including the 2005 card systems hack that exposed over 40 million credit card records and forced the industry to rethink how saved data was handled on the client side. You're watching Trend Flow, where we explain the tech that runs your life. And today we're going to dive into the fascinating world of Autofill, exploring its inner workings and the cutting-edge technologies that power it. From the early days of password management to the latest advancements in biometric authentication, we'll take a closer look at the evolution of Autofill and how it has become an essential tool for navigating the online world. Whether you're a tech enthusiast or just a casual user, understanding how Autofill works can help you appreciate the complexity and sophistication of the digital systems that surround us. So, how does Autofill actually work under the hood? When you first create a login for a website or app, your browser or device stores the credentials in a secure local database. Chrome, for example, uses a SQLite database file called login data, and on Windows it encrypts the contents using the Data Protection API, known as POPI, which ties the encryption key to your Windows user account. When you revisit a site, the Autofill system reads the page's HTML and looks for input fields with attributes like autocomplete equals username or autocomplete equals current password. It then performs heuristic matching, analyzing the page URL, the form structure, and even field labels to determine which stored credentials fit. If the URL domain matches a saved entry, the system populates the fields. If it detects a new subdomain or a different form layout, it may prompt you to confirm before filling anything in. But here is what most people do not realize. Autofill is not just about storing and filling in credentials. It is also about layered security. Microsoft Authenticator, for example, stores credentials in an encrypted vault on your device and syncs them across devices using end-to-end encryption tied to your Microsoft account. It also supports time-based one-time passwords, known as TOTP codes, which rotate every 30 seconds using the HMAC-based algorithm defined in RFC 6238. On top of that, many autofill systems apply password hashing and salting before storing anything. Salting means a random string of characters is appended to your password before it is hashed, so even two users with the identical password end up with completely different stored values, making rainbow table attacks essentially useless. Apple took a different approach with its dedicated passwords app, introduced in iOS 18 and macOS Sequoia at WWDC in June 2024. Before that, Apple's password management lived inside settings under the iCloud keychain section, which debuted back in 2013 with iOS 7. The new standalone app organizes saved credentials, passkeys, verification codes, and Wi-Fi passwords into a single searchable interface. Under the hood, iCloud Keychain encrypts data with S256 GCM and protects the encryption keys with the Secure Enclave, a dedicated hardware chip on Apple devices that processes biometric data like Face ID and Touch ID without exposing it to the main processor. This means that even if someone cloned your device's storage, they could not decrypt the vault without physical access to that specific Secure Enclave chip. There is an important technical distinction between autofill and autocomplete that most users blur together. Autocomplete is an HTML specification maintained by the Web Hypertext Application Technology Working Group, known as WHATWG. It defines a set of standardized field tokens, such as given name, street address, CC number, and that tell the browser what kind of data a form field expects. Autofill is the browser-side feature that reads those tokens and supplies the matching data from its stored profiles. When a web developer forgets to add autocomplete attributes, or worse, sets autocomplete equals off, the browser's autofill engine has to fall back on heuristics, scanning placeholder text, label elements, and even the field's position in the form layout. Google Chrome's autofill engine, internally called the Autofill Manager, uses a set of regular expression patterns for over 30 languages to detect field types even when no HTML hints are present. This layered system has a direct impact on how you should manage your own security. Since autofill relies on matching URLs and form fields, you should be cautious about browser extensions that modify page content, as some malicious extensions have been caught injecting invisible form fields to harvest autofilled data. In 2017, Finnish web developer Viljami Kuusmanen demonstrated this attack publicly, showing that hidden fields could capture a user's full name, email, phone number, and address the moment autofill populated even a single visible field. The demonstration prompted Chrome, Firefox, and Safari to restrict autofill so it only populates fields that are actually visible on screen. You should also avoid using autofill on shared or public computers, and if you do, always use a private or incognito browsing session, which does not have access to your saved credentials. Autofill also plays a measurable role in defending against phishing. Because the autofill engine checks the domain of the page before populating credentials, it will not fill in your banking password on a lookalike domain. If your bank's real URL is bankofamerica.com and a phishing page uses bankofamerica-secure-login.com, the autofill system sees a domain mismatch and leaves the fields blank, giving you a visual warning that something is wrong. A 2019 Google security study found that users who relied on Chrome's built-in password manager were significantly less likely to enter credentials on phishing sites compared to users who typed passwords manually. Password fatigue contributes to this problem as well. When people manage too many credentials by memory, they tend to reuse the same password across multiple sites, and a breach on one platform cascades into compromised accounts everywhere else. Dedicated password managers like 1Password, Bitwarden, and LastPass extend autofill capabilities beyond what a browser offers natively. 1Password, for instance, uses a dual-key encryption model where your vault is protected by both your master password and a 128-bit secret key generated during account setup. Neither key alone can decrypt the vault, so even if 1Password servers were breached, the attacker would still need your locally stored secret key. Bitwarden takes an open-source approach, publishing its entire code base on GitHub for public audit, and it has undergone third-party security reviews by firms like Cure53. These tools also support cross-browser and cross-platform autofill, injecting credentials into desktop apps, not just websites, using system-level accessibility APIs on Windows and macOS. The next major shift in autofill is the move toward passkeys, a passwordless authentication standard built on the FIDO2 and WebAuthn protocols developed by the FIDO Alliance, whose members include Apple, Google, and Microsoft. A passkey replaces your traditional password with a cryptographic key pair. The private key never leaves your device and is stored in a hardware-backed secure element, while the public key lives on the server. When you log in, your device signs a challenge from the server using the private key, and the server verifies the signature with the public key. There is no shared secret to steal. Google began rolling out passkey support across its services in May 2023, and by October of that year reported that over 400 million Google accounts had used passkeys at least once. Apple and Microsoft followed with their own rollouts tied to iCloud Keychain and Windows Hello, respectively. These passkeys are also synced through autofill infrastructure. On Apple devices, passkeys sync via iCloud Keychain, meaning a passkey you create on your iPhone is immediately available on your Mac and iPad. On Android, Google Password Manager handles the sync, and third-party managers like 1Password and Dashlane added passkey storage support in late 2023. The FIDO Alliance published a draft specification for cross-platform passkey portability in February 2024, aiming to let users export passkeys from one ecosystem to another without losing security guarantees. This is a significant step because one of the early criticisms of passkeys was vendor lock-in, the fear that choosing Apple's ecosystem would strand your credentials if you later switched to Android. Subscribe to Trend Flow and join us next time as we explore the hidden features and secret technologies that power our digital world.